The biggest challenge facing security teams right now, vulnerabilities. There are too many to fix and teams struggle with prioritization. Our new report shares real-world cloud and container findings for practical ways you can prioritize vulnerabilities and reduce risk, as well as exposing the tens of millions of dollars in wasted cloud spend due to over-allocated capacity. Dig into real-world data to understand cloud threats, security practices, and container usage patterns. Download your free copy of the report at sysdig.com.
Awesome. Hello, everybody. I am Mike Isbitski, Director of Cybersecurity Strategy here at Sysdig. And I'm joined by my colleague, Crystal. Do you want to introduce yourself, Crystal?
Yeah, hi, I'm Crystal Morin. I'm a threat research engineer at Sysdig. And Mike and I are both co-authors for this year's usage report.
Yes, quite a bit of work. So we're gonna spend a lot of time today talking through kind of the three main themes. There's a lot of trends that are observed there. I'd encourage you to definitely download the report, ask questions today if you can think of them. Sometimes there's a lot of information, right? You have to unpack these things, and if you think of them later, please do ask those questions. We're all readily available in all kinds of mediums. So hit us with your questions, please. All right, so we got our slides up. There's a handy dandy link to the report. Well, let's start with kind of one of the bigger themes, which is that 72% of containers live less than 5 minutes, which is pretty astounding if you think about how fast 5 minutes moves in our lives. My toddler son takes him about 5 minutes just to walk down the hall. But if you think about how many things can happen in the course of 5 minutes when you're thinking about production availability or preventing attacks, it's massive, right? In 5 minutes, somebody could bring down business critical applications or your entire infrastructure. And modern systems are architected on containers and Kubernetes. So we'll be talking through a lot of those concepts today. We're going to come back to this particular theme or trend because it just impacts everything, but it's a very big mindset shift, particularly if you're coming from the world of bare metal or virtual machines where things just live much longer. That kind of affords you a lot of time, right? And it is a luxury. So newer architectures, ephemeral architectures, it's a very different world. You kind of have to rethink how you approach everything, whether it's IT or security. What I would like to call out too about the usage report is that it's based on data from actual Sysdig customers. We do not use surveys for this. It is real world data. It's based on observations of billions of containers, thousands of cloud accounts, and thousands of applications over the course of a year. So it's a very realistic picture. Yes, it's a subset, right? We're talking about Sysdig customers specifically, but it's really interesting when you think about that in the context of security trends we're observing, particularly if they look bad, which some of them do. We're going to talk a little bit about that today, but we have to remember that these are actually organizations that have acknowledged there's problems that need to be addressed, right? And they've sought out tooling from Sysdig to address that. So. We're not pointing fingers today. Nobody's making mistakes. That's kind of a common security pitfall. The stuff is tough, right, or difficult. So hopefully we can, by highlighting some of these trends, we can give you kind of more ideas and guidance around how you can approach security operations. All right, so the three themes as advertised, right? Container risks are growing. We're going to talk about kind of vulnerabilities and zero trust. We hear a lot of discussion around zero trust for years. What does that mean? We're going to dive a little bit into that in the cloud context, particularly cloud identity. And then cloud costs are running away. This is a really big problem for organizations, particularly over the past year or so, just because most organizations have had to make difficult decisions around budget or headcount, right? Just because of economic difficulties, right? We're kind of in a kind of weird times, right? Things are just a little more costly, right? So everybody is scrutinizing spend in different ways. And that does pertain to containers and cloud. So we ran a poll for this particular session, and it was kind of curious to see where everybody landed in their answers to this. Again, there's no right or wrong answers. This is really just kind of perceptions, because to me, those perceptions are telling. That's often how you're going to approach a security program as well, right? Maybe you focus on shift left, maybe focus on shield right or runtime security. There's a lot of different approaches, right? But this one in particular was interesting, I think, because everybody kind of hit the nail on the head, or the majority did. And it is 87%. We're gonna.
They read the report before jumping onto this today.
Yeah, exactly.
Good job.
Here and looked ahead, maybe, but they didn't get through the full report. So we're gonna talk through some of the usage stats. But yeah, this is kind of alarming, and it's funny. Like, is it security practitioners, and their mind kind of goes to worst case, so pick the biggest number. 75% was actually the number last year. So it's interesting that everybody kind of, or majority hit this one. The numbers are close, right? None of these are good. You would hope that none of your container images have vulnerabilities. So yeah, this is the trend that we observed. 87% of container images have high or critical severity vulnerabilities, right? And those things are production impacting, right? If you think about it, if somebody's able to exploit these particular issues, you can have very far-reaching impacts to your infrastructure and applications. Crystal, did you have any thoughts on like how is this, the impact? Was it surprising to you authoring the report?
Surprising and also scary, right? This isn't a number that we want to see go up every year. It went up 12% from last year, 75% of high and critical vulnerabilities. That's not a good thing. Coming from the threat research background, I think that one of the reasons that this number is going to maybe continue going up, or at least stay the same for now, is because more threat actors are targeting cloud and container vulnerabilities. More and more of us are starting to move into this world from on-prem VPNs, things like that. So we're going to start seeing more of these come to light as our adversaries are also focusing on them.
Yeah, it was interesting for me to see this trend up as well, right? And it's this is also it speaks on a few things. It's kind of what's the hygiene of everything that's out there? Where are people sourcing container images? There's lots of kind of nuance to this. It's kind of unfortunate that it is getting worse, like the numbers going higher, but it could also be that organizations are scanning more, right? So they're seeing these CVE IDs. There's just a lot of sub-stories that are kind of buried within this. And tied very closely with this is something we've been tracking at Sysdig. We have capabilities now on this front, but I used to get this question all the time, research and advisory work, even when I was a practitioner and doing the testing. I was often asked, is the thing exploitable? What's the actual impact if somebody exploits this issue? Is it actually used, right? Because you run into this problem of third-party code. But this is a really common problem, right? Security teams struggle to prioritize risk. So if you think about the number of packages that have higher critical vulnerabilities, that's going to translate to very high CVID counts, right? And then you might be staring down a backlog of, 100,000 vulnerabilities. It's like, where do you start? How do you fix this? Is that the security team? Is that development teams? Like, is it your supplier, right? These are kind of the realities of vulnerability management in modern systems. So when we were authoring the report, and Crystal, I'd love to get more of your thoughts on this, but we wanted to dive deeper, particularly like those things about exploitability. Is there a fix? What's in use? Crystal, did you want to share any of your thoughts on this particular trend?
Yeah, sure. So obviously we see vulnerabilities all day, every day in the news, right? If you're a cyber threat intel personnel and you're constantly reading through OSINT, you're going to see vulnerabilities popping up all the time. You're pushing them to your incident responders or your threat hunters for them to work on, right? But with vulnerabilities coming to your teams every single day, which ones matter the most is what we wanted to focus on. Let's reduce some of that stress on our security teams. And the biggest jump we saw was in use at runtime. Only 15% of these vulnerabilities have a fix and are in use at runtime. So that makes it much more manageable. The 71% isn't very good. There's a fix available and we're not patching them, but you know what? Only 15% of them are being used at runtime. So that's a good starting point for you to focus on. And then exploitability, of course, too. The 2%, you'd want this to be 0, right? You don't want to be running an exploitable CVE. But maybe there's a reason that your company is running it. Weigh the risk to the reward for running that image, right? But if you're looking at prioritizing your vulnerabilities, that's what you should focus on first. Make sure that you can't be exploited. These exploitable ones means that there is a proof of concept out there in the open. So defenders and adversaries are both aware of what's going on. And then, like I said, above that, if you're using it, make sure you patch it if there's a patch available.
Yep. Yeah, and there's a lot of things here at play too, right? Like patching. Sometimes I hate to use the term patching because it's a little bit of carryover from old world. Like when you're talking about container environments, it's not always as simple as, well, click a button, apply the patch. Like you're talking about referencing new dependencies, new container images. You can break the application, but also break your infrastructure, things like Kubernetes. So patch is kind of one of those misleading terms, but the language is there, right? That's kind of the language of CVE and CVSS. So yeah, is it fixable? Yes, it helps reduce that count a little bit, but it's also really important to kind of think about that, right, in the context of testing, because this is usually one of the biggest problems that happens is, the more you scan, the more security vulnerabilities you find, and you're always looking for ways to kind of narrow that down. And if you're just zoning in on, was there a fix available? It doesn't change the number drastically, but it also doesn't account for third party, right? So your supplier or third party now has to actually fix that. So it kind of becomes maybe you lobby an open source project to fix the issue. Maybe you do a code contribution. There's just a lot of nuance to that. So security mindset is kind of like, there's a fix available, or we have all these issues, why aren't we fixing it? And it's just not that simple, right? These are kind of operational realities for organizations. And again, these are kind of companies that have reached a different level of maturity that they're actually seeking tooling to help them with these problems. So yeah, the in-use concept is huge, right? This is something I got quite a bit in advisory work. Is there a way to know, all right, we're seeing these things in scanning, but what's actually in use at runtime? Because that's a much more addressable problem for all our teams.
We have someone that wants to know what we mean by in use at runtime.
Yeah, good question. Do you want to take it, Crystal? I mean, I can certainly dive in. I could talk. I don't want to fill up the whole stream. I'm sure everybody wants to hear you.
You can go ahead.
Yeah, so it's I used to hear this quite a bit with reference third-party code or open source libraries. What happens typically in engineering is you're going to reference more than you need, and you might not actually use that functionality in the running application, right? Maybe there's some coded functionality that existed at one point. Maybe that got pulled back. You needed that library. Now it's not necessary, but the reference in code is still there. So that becomes part of your running environment in your containerized application. It's there. So is it reachable in code? Is it referenced? Like all of those things kind of play into it. And that's kind of what we mean by in use. But now, Crystal, I would be curious, like for the threat side of this, like, what does that in use mean, right, for attackers?
Yeah, so also in the report, we also dive into this and we call it image bloat. So the not in use is all of the code in these third-party images that you're pulling from other vendors that you're not writing yourself, that you're not actively using. This code was written into this image, but it doesn't pertain to your systems. So it's not being run. This image bloat can increase the time it takes to run images. It can increase the cost. It's going to slow down your work processes because these images are larger than they need to be for what you need to accomplish. So with this, if you can focus on reducing your image bloat, you can reduce your vulnerabilities. If there's code sitting in your images that you're not using, it's tedious to go and take it out to get probably DevOps, right, to work on this and reduce the size of your images. But there's going to be less vulnerabilities sitting in your images. Your code is going to run faster, more secure, and it's going to cost your company less.
Yep. Yeah, good stuff. Yeah, and this will play into availability too. We're gonna talk about usage later, but yeah, the image bloat is definitely a factor, right? It's just not going to be as performant an application, as well as an exploitable one potentially. And this does play into software supply chain. We talk a lot about this at Sysdig, but as I was saying earlier, the way that organizations and practitioners build things does tend to be through code-based approaches, and particularly container images, right? That's how we're instantiating infrastructure and workloads that power applications. So when we're talking about vulnerabilities in container images, this actually becomes a big part of software supply chains or digital supply chains. So everything you're doing, this is a big factor, but also your partners and suppliers need to be thinking about this also, because they're connected to your environments in different ways. They may also be sourcing these same vulnerable images, and are they scanning in build time? Are they scanning in runtime, right? All of this plays into that bigger picture of software supply chain risk. This is a fun one. I've addressed some of this in journalists often ask this, and I used to get this actually in advisory work, like how does zero trust play into application security? But it's also part of cloud permissions, right? I'm backing up a little with zero trust architecture. Often there's an emphasis on securing network perimeters or micro perimeters. You get into things like segmentation and zoning, microsegmentation, network isolation. It's very much a network-centric idea, or at least that's how practitioners often approach it. But there's a lot more to zero trust architecture, particularly identity, right? And identity isn't just user identities, it's also machine or service identities. There's a lot of things you need to permission in order to get something like Kubernetes to work, or your applications might need specific permissions just to operate, right? And you can't challenge those identities the same way. It's going to break everything, right? It needs to be seamless. It needs to be automated. So presenting something like a 2FA challenge to machine identity is just never going to work. So the world of zero trust it's very human centric and network perimeter still, unfortunately, and that needs to change. But we actually saw this in the data, and that's things are just over permissioned in cloud tenants or cloud subscriptions. And particularly, we saw that 90% of granted permissions are just never used, which was pretty alarming. Crystal, what was your reaction when you saw this particular stat?
This isn't good. Like we said, zero trust clearly isn't working quite yet in the cloud. It was a little bit of a surprise. I mean, everybody talks about it, right? You hear about MFA everywhere. So why is it not being implemented? Like you said, maybe it's because these are third-party vendors. They're applications where there's no human being behind the keyboard, so they can't necessarily respond to MFA. So there's no MFA implemented on those accounts versus a human account. We did state in our report that we saw the number of human accounts versus non-human accounts go up this year. So that's good. Maybe, again, like I said, more of us are going to cloud and container usage, so there's more personnel involved in this, right? Or it could be that we're not relying as much on vendors and applications. But still, this number came from no MFA enabled, and admin accounts, how many of their permissions did they use over a certain period of time? Obviously, you're not going to be using all of your permissions all the time, but when you're granted permissions for your role or projects or a teamwork that you're working on, sometimes a team of, say, DevOps can be provided with certain permissions, or one user account that say 5 people will use to get a project done. Once that project is complete or that group is disbanded, that account should be closed and thrown in the garbage. Leaving those kinds of things open are going to increase your risk to adversarial compromise. Obviously, 90% of permissions is going to give an adversary a good opportunity to get into your network. And that's not something we want to do.
Yeah, and they may not be monitored, right? We were talking about this internally, like they were provisioned. The engineering team said, yes, we absolutely need these. Stop questioning us security or compliance, right? And signed off, and then lo and behold, it never gets kind of looked at again. But that usually translates into monitoring. Specifically, they might just fall off the radar, right? You're going to look at the kind of more active user base. So yeah, it's pretty bad, if not as bad as it gets for the security story. I like that Crystal called out too, that split with human and machine identity. I was kind of surprised to see that trend down, although I think it is exactly what Crystal said. Just more user identities being provisioned in cloud. It's not that there's less machine identities being spun up. It's just that there's just that many more human users that need to exist in cloud subscriptions. But that will probably switch back, right? Because automation is the name of the game. I think everybody kind of knows Chat GPT, but API enabled integrations, automations, all of these things translate to machine identity. MFA is great for a human user, really not feasible for service identities.
We've got a couple of questions on this I can address too.
Oh, nice. Okay. Yeah.
Aren't excessive permissions the easiest way to get stuff to work, get stuff done? Yes, absolutely. If you have all of your permissions, then you don't need to go to somebody to go ask for them to add a permission and wait for that to continue your project, right? So yes, of course, giving permissions, you can get your work done. But that's why we got to this number, and you're just leaving opportunities. Say you're granted admin access for one project. Now you have admin access that gives an adversary an opportunity to move laterally through your network with no problems. If you have 15 admins instead of one, that's just more opportunity for an adversary to move and compromise your organization. The other one is it really possible to rigorously manage this at scale? It's possible. It's really hard. There's plenty of large organizations that do have IAM teams. They have identity and access management, but it's not easy when you have hundreds or thousands of people. They have all of these permissions that they're using, and these permissions need to come and go. They're on different projects. Now your one person has 15 different permissions, and when you compound that by such a large company, yes, that's very hard to manage. But it is doable, and it's something that we all need to be aware of. This isn't just something that an access management team can take care of. When you're done with the project, you could be proactive too and ask that those permissions are turned off if you don't need them anymore. Do you have anything to add, Mike?
Yeah, I mean, I don't want to kill all of the time, but it's a couple things, right? Zero trust we need to do that, right? It's kind of least privilege always, and always assume that the environment is compromised, regardless of that's endpoint, cloud, wherever you're operating. Always assume that environment is compromised. So you need to be doing least privilege all the time. It's exactly what Crystal said. Provision and deprovision as you need that. Yes, that's hard to do. You start getting into things like privileged access management, secrets management, which it's going to be more than we can cover today. But yes, it's a big technical challenge. And it's interesting with identity access management teams. I've definitely seen that, right? Kind of as organizations grow and get more identity, IAM teams often grow as part of that. But it's kind of like a moving target, right? They're just dealing with more identities as well, and might not be enough staff to actually keep tabs on everything, right? So you still need the tooling to kind of keep tabs on everything to kind of follow zero trust architecture practices.
And just real quick, one more. So the risk if
Oh,
these
nice.
logins
Okay.
are never used. That's a good one. What's the risk if these logins are never used, right? So they're just sitting there. It's an opportunity for an adversary. This account hasn't been used in 90 plus days. No one's logging into it. So if an attacker logs into this account that has, say, admin permissions and nobody's using it, you're not going to notice because you're not using this account. Two, your detections are not going to pick up on something like that per se. If you have a detection that might alert on accounts being logged into after a certain amount of time, then yes, that would work. But again, that's just kind of another risk. If this is sitting out there, it might not be something that you pick up on. It'll just look like normal user activity.
Yeah, absolutely. Yeah, and there's kind of the operational side of it too, right? You're creating more of a workload for other teams. There's also audit risk, right? You have these things you might fail. If you get an external auditor to come in, they might be questioning this. So it creates a lot of other problems. You should still be thinking about it and a lot of these other terms as well. Good question though. Yeah, it's like if it's not being used, what's the risk?
Right.
All right, I think we're good on this. A lot of questions. That was good to see. People aren't tired of zero trust yet. All right, so we're going to move on to the usage trends. There are a lot more security trends in the report. Again, please take a look at it. But these were kind of the big heavy hitters, and they tend to resonate with a lot of practitioners and leaders. So that's kind of what we've cherry picked for these sessions. Usage. So I know not everybody is in the world of containers or Kubernetes. Maybe you're dipping your toes in the water. Maybe you're using Docker on your desktop and you're kind of tinkering with containers in like kind of a lab environment. But you might also be in the world of Kubernetes and running production grade container clusters, right? And that's typically what happens. You need an orchestration engine to run all of these containers at scale to support production infrastructure and production workloads. That's really where Kubernetes comes in. So what we saw was that cluster sizing impacts cost dramatically, and that's particularly organizations that were running over 1,000 nodes, which is a lot, right? You wouldn't often expect to see that. That's kind of maybe higher tech, or maybe it was just how they opted to build their clusters. Personally, I think that's a pretty high number. That's a lot to manage, but what we saw was that they could save over $10 million annually. So huge impacts for kind of the cost angle. Crystal, I was curious, did you have any kind of like perspective from the threat research side of this? Like, does number of nodes matter to an attacker? Do they prefer those?
Yeah, so I mean, it's just more opportunity for them, right? The more nodes there are, the more images, the more containers. So the number of vulnerabilities that you're going to be at risk for is going to expand exponentially, as is this cost that you're looking at, right? So more pods, more containers. If there's a lot more nodes, then there's a lot more risk that you could be vulnerable to an attack. It would be more likely for an attacker to hit a large organization like this because they know that that one vulnerability is probably going to be present in one of those 1,000 nodes.
Yep. Yeah, it's just a lot more noise too, right? Think about it, it's just a lot more things communicating, and it translates into other problems too on cost, definitely, but availability. So yeah, this was interesting. Interesting that organizations are running clusters that large, Sysdig customers. I used to get this question sometimes in advisory. Is it better to run a large cluster with many nodes and less number of pods in those nodes, or vice versa, right? Fewer nodes and many pods on them. There's a lot to unpack there. It's kind of a design decision, but also operational. Like how kind of are you approaching things? How are your teams structured? Conversation. So there's no right or wrong answer to that. There's just potential impacts when you get to these large size clusters with many nodes, particularly on the costs or cloud consumption. And the other thing that kind of parallels with this, right? Because I'm saying like that's kind of rare to see a cluster that's over 1,000 nodes. Well, what does that mean for organizations that are running smaller Kubernetes clusters? And we still see that they're overspending by 40%, right? So even if you are running 100 or 200 nodes, you're still allocating more compute than you need. That's going to be driving up your procurement bill, whether that's cloud expense or on-prem if you are self-managing Kubernetes. You have my condolences, right? Kubernetes is a beast. Most organizations do run managed Kubernetes. So there's always kind of this cost savings that you can realize by kind of scrutinizing that, right? Do we need this much? And this, it's kind of carryover. Like this is what I used to see in traditional data center days. Like teams would always over provision, right? Because they needed it or they thought they were going to need it. So they forecast out. That's not necessarily the world of elasticity or having ephemeral compute, right? You can get what you need when you need it if you're doing things right. That there's technical hurdles to jump over to get to that point, but you don't need to over provision. It's just kind of almost human nature. Like let's just put more than we need, almost like the identity problem, because we don't want to create availability problems. So this is just another way that kind of human nature manifests in designs. I'm going to move on. And that's that lifetime, right? So let's kind of re-examine this particular one, and it's kind of bubbled up throughout the session, and that's 72% of containers live less than 5 minutes. There's actually a nice chart in the report that breaks this down and what we saw for the different percentages, but some organizations that might only live for 30 seconds or a minute. So that's almost more like a serverless architecture you might expect. And right with serverless, that it's abstracted. It's typically containers under the hood anyway. It's just not something you operate. That's very short, right? So 5 minutes is really short. 30 seconds is extremely short. This has massive impacts for incident response, which I'd love to get Crystal's perspective on, like when you're tracking down threats, like what does that mean? But for availability, it's huge, right? How do you actually calculate baselines? How do you retain logs? How do you audit your environments to know what is properly allocated, right? So 5 minutes, if you take nothing away from this entire session, it's just know that containers are kind of tricky beasts, right? They're very short-lived. You have to kind of rethink all of your approaches when dealing with them. Crystal, did you have perspective on this from like the threat side of things?
Yeah, so there's a couple of things that I can touch on for this lifespan. The first one being that if you have vulnerabilities in these container images that are spinning up and down every 5 minutes or so every time it runs, it is, unless you're fixing those vulnerabilities, you are reintroducing yourself to these vulnerabilities every single time this container runs. So it's not just happening once, it's also not sitting out there in the open, which I guess you could say is good too. But you're putting yourself out there for an adversary. They're sitting out on the internet. They're looking for a certain vulnerability, and your container spins up. They can see that and they can get in just in that 5 minutes. The struggle on the other end is once that 5 minutes is up, you might lose your forensics data for that container, right? The container is dead. It come down. It's not alive anymore. And a lot of organizations only hold data for a certain period of time, whether it be a couple days, 90 days, some hold this log data for much longer. But these containers spinning up and down so quickly, you're going to use your log storage, and that's going to, you're going to end up losing your forensic data as these containers spin up and down. So you might not be able to see that you are vulnerable or that there is an attack because your data is phasing out. So it makes it very difficult to address. It just points to the need for continuous detection, threat hunting, and then again, going back to reducing your image bloat, focusing on those vulnerabilities that are in the images that are running every 5 minutes too.
Yeah, it's definitely a good one. Yep. So let's move on for the sake of time. And again, if you have questions, please do put those in the chat. The other thing I would say too, from the application security perspective is that we have to remember that container orchestration, that whole business, it's going to spin up the container that is needed to support the application function. So the container might not be live at that instant, but if an attacker finds an exploitable function in your application, they're going to target that. And guess what? It's going to start up the vulnerable container to do so. So it doesn't really address the problem. It's kind of like you have to think about these security challenges in like a different way, right? It's kind of much different from that bare metal server or virtual machine, like an instance of something I can almost put my arms around. Containers are just much different, right? They're spun up as you need them. All right, so and we have a poll, right? So this was actually a good one also, because the audience didn't nail this one on the head. They actually went even farther, right? Which the question was, on average, what % of requested CPU cores in Kubernetes clusters? That's a mouthful. Do you think we found unused across all Sysdig customers? So the audience thought it was more, right? 77% was unused, which is interesting, right? It's like maybe people are kind of aware that Kubernetes is beastly, right? It's going to kind of spin up a lot that you might not need anyway, let alone you might not have a good handle on your application workloads. So the audience overshot there. It was actually 69% that we saw with Sysdig customers, which still went up, right? We saw this last, I think it was roughly 50% last year. I believe it's on the next slide. Up from 34. Yeah, so it doubled, right? I underestimated that one. So this one's interesting, right? It's a little bit like the node size, although, right, because we're thinking about availability, we're going to over provision, and then our workloads just have way more CPU than they need. That's going to translate to cost. And this one's kind of interesting too. I was thinking about this a little bit more from like security angle. Does this impact like denial of service conditions? Because you can't really know what, if you don't have the baseline to know what is the right amount of CPU you need for that application, how are you going to know if you're actually having a denial of service? And quite honestly, just with kind of operating Kubernetes, you can DOS yourself just trying to spin up an architecture and get some workloads going. So this definitely has ramifications for security, but Crystal, I don't know if you had more perspective from the threat angle. I know sometimes this is kind of more of a business context and just over allocating.
Yeah, exactly. No, you hit it on the head. This is over allocation, and really the only way to try to start reducing this and getting rid of that unused CPU is baselining your apps and dependencies. Look at what you're actually using, and then you can reduce what you use every month.
Yeah, and it's easier said than done, right? Well, it's very easy to say in a session, very difficult to do in practice. That's why,
as is with all of these, but yeah.
Yeah, observability, right? And it's like that whole ephemeral architecture. Do you even have the right log data to do that? How do you actually calculate a baseline? It's one of the things Sysdig does in our tooling. But yeah, this is interesting to see this kind of trend up. So definitely plays into kind of that whole cost consumption and curbing your cloud costs. And that should be it for the trends. Really quickly on Sysdig, and I want to save some time just in case we got more questions that rolled in. Sysdig has been in the space for a while, very mature company. Falco is kind of our threat detection and response engine. It is open sourced, so you can take a look at that. And Sysdig open source is kind of that telemetry gathering engine that can feed Falco. So kind of two very necessary tools or componentry that are kind of fundamental to cloud and cloud native environments. You'll find that they actually exist in a lot of service providers, although whether they're upfront about whether they use the capabilities, it might be buried in open source terms and conditions, but it's there, right? So Sysdig builds these tools. It's also the building blocks for the Sysdig secure platform. We have many large customers that are operating Sysdig, which is how we're able to get this really awesome data set to bring these trends to you. Yeah, that's kind of it. So I think we have a few more minutes. Did we get any more questions, Crystal?
We got one more. Okay. So this goes back to the vulnerabilities and our breakdown of them, prioritization. I don't understand why organizations are running so many images with exploitable vulnerabilities. Do you have any reasoning for this? I can kick it off real quick. Not really. Like I said before, it might just be a risk that they weighed. These are exploitable vulnerabilities with fixes available, whether that be a simple patch or it might be somebody going back through the code and correcting the code. It might not be that easy. So it could just be a shortage as far as employees go, capabilities to fix something like that. And in my opinion, it's just a matter of weighing the risk between needing that image and having to run it versus having the capability of being able to fix it.
Yeah, it's definitely accurate. I'd say one thing I saw, particularly like advising around application security and application security testing, is a lot of organizations, well, it was traditionally scanning in production, right? Like, let's scan our network infrastructure and know all of our vulnerabilities, but that kind of really only worked for traditional data center environments or maybe virtualized environments in cloud. As you move into containers, you kind of have to shift that left, right? That's why the term exists, but it was also a byproduct of DevOps. Really what it translates to is you're going to be testing much earlier and often, particularly as part of continuous integration and continuous delivery, CI/CD build pipelines. But a lot of organizations kind of get in a bind where they'll start scanning everything and they have kind of the same problem they had historically with vulnerability management when they're scanning production, which is it becomes this pile of vulnerabilities, and it's how do you triage that, who fixes it, which engineering team is even responsible, right? Because if you think about a large infrastructure and application, it's going to have many teams that build and operate different components, so might be multiple owners of different tasks. So it's a big problem, right? But now you've introduced it early into the life cycle, and then you get kind of stuck in release decisions. And that's kind of a no-no, right? In the world of DevOps, when you think about release velocity, this kind of stands opposed to that. You're going to be kind of extending things out. So yeah, unfortunately, organizations have to kind of make that risk decision, and they might just bite the bullet and be like, we have runtime security mechanisms. Maybe they have their SIM in place. They're confident they're going to stack things. Might not be entirely true, but that is kind of the reality of runtime security. At Sysdig, we approach it differently, right? We're kind of gathering telemetry everywhere and securing all types of workloads and all types of environments to detect those issues. So yeah, it's a tricky question. It's like, I don't think they're deliberately ignoring it. They're just kind of like between a rock and a hard place. It's kind of the realities of modern business operations. We got quite a few other questions rolling in, so.
So I think some of these are pretty quick and easy, so we can just go over these again. Tips and tricks for how to avoid millions wasted on unused Kubernetes resources. Baselining, first of all.
Yeah.
Right. We'll go back to image bloat. That's another one. Reducing the bloat in your images will also reduce the cost. You're
and it's
spin up faster.
Yeah, I mean, it can all be restricted, right? These are mechanisms that are built into Kubernetes. It's just kind of what tends to happen is organizations are running too many workloads, and it's just too hard to get ahead of that, predefining everything in code, or they're worried about the availability impact. So at some point, you need tooling to assist you. But yeah, there's no shortage of kind of materials to help guide you allocate properly from the get-go. It's just kind of day two, right? What happens then when this thing's live, and then it starts to grow legs, and your manifests change, and app teams start requesting more resources. So you kind of need tooling to help inform that.
I'm going to grab two more questions, I think. Thoughts on why the non-human roles decreased from 88% to 58%, and the human roles increased. Do you want to start on that one?
Yeah, this I touched on it briefly, but we didn't give it a lot of time. I think some of it could have been kind of pandemic related, where organizations kind of pulled back and then hired, right? So we saw a lot of market was booming a little bit, right? And now we're kind of back in the down cycle. So a lot of organizations were hiring. Those workers need identities. So that's a pretty basic explanation. I do think it's going to shift back. I don't know if you had quick thoughts, Crystal.
Just personal opinion. So like you said, I think there's just more personnel being hired, more organizations are using this more broadly across their org, more people. But I think another thing could point to maturity, the decrease in non-human roles. Organizations are maintaining things themselves or using less vendors. So there's less third party and applications on that non-human side. Okay, so last one. Do you have any sense for how much of the poor practices are knowledge and skill-based shortage and mistakes versus consciously accepted risk?
That's a good one. I don't necessarily think, this is, it's going to take more than a minute. You shouldn't have picked this one up. It's like, and I don't think that, I really hesitate to ever fault an organization that they're not following practices and shame on you, right? You did the bad thing. And it's like, there's a lot of problems at play. We can start talking about staffing and recruiting, like how do you find talent? I hear a lot from different organizations and Sysdig customers, right? It's not often that they can't find people. It's more that they don't necessarily have the tooling that gives them visibility and something that they can automate their security around. So sometimes it's that tooling discussion, but you also have bigger forces like digital transformation, and like sometimes organizations are just kind of in like a state of upset where a lot of things are being revamped on the process side. So that unfortunately translates to misconfigs and broken process.
Yeah, so I don't think I would necessarily say that the poor practices are much of the knowledge and skills. There's a lot of very intelligent folks and a lot of really great companies that you can use to help you with that. As far as accepted risk, I think the conscious versus unconscious leans more towards the maturity of an organization. An organization who's new to using cloud and containers is going to unconsciously accept more risk, right? They don't know, they're learning. They might be getting fed and assisted from third-party vendors. But then somebody who's trying to mature, they're writing their own detections, they're creating their own images, they may or may not accept more risk. But again, like you said, this is kind of dependent on every organization themselves. But I think maturity does have a big play in it, for sure.
Yeah, and of course that came from Anna, former Gartner analyst, asking the curveballs.
All right. We've got one more if you'd like.
I'm not sure how to answer this one particular. I'll punt to you, Crystal.
We can get back to it. I think we'll wrap.
Yeah, that one. But we'll get more details on how to answer that one appropriately. So great question. Thanks everybody for attending the stream. And Crystal, thanks for joining me and co-presenting and sharing your insights.
For sure.
It's definitely nice to get kind of the threat research angle on this. So yeah, please everybody download the report. And again, if you have questions, please do reach out to me or Crystal or anybody at Sysdig, right? That's kind of what we're here for. We live and breathe cloud and containers. Sometimes we take this stuff for granted. Some of you are earlier on your learning journey. So there's a lot to navigate. So please do reach out. With that, thanks again, everybody, for attending the stream.